Hi, this is Larry. I'd like to talk a little bit today about object-oriented concepts. You probably have had a lot of questions. You've heard the term object-oriented. You may have heard it related to object-oriented programming, OOP, or again, OOP as object-oriented practices, or OOP as object-oriented principles. Let's go over some of these concepts because it's very important as a programmer that you understand them. So what we're going to do is go over some introduction to these concepts, the value of it, why, talk about why it's being done, and then basically looking at some of the basic simple fundamentals behind it. What you have to keep in mind is that object-oriented are design principles. As we've talked about, is that before you begin program, you need to analyze and then design what you're going to be putting together. And what object-oriented more than anything else are the principles behind it are related to how you design object-oriented programs. When you go to programming that then, they become programming practices. Simply put, that some languages have, most languages today, have object-oriented programming practices inside of them so you can implement the object-oriented design principles. Please understand that if you're doing C, C++, C#, even doing Java, okay, that you could actually code and write programs that are not object-oriented. Even though the languages of C++ and C# and Java have object-oriented to them, you can get away with actually running a program and developing it without ever implementing any object-oriented principles inside of it. So remember, object-oriented is a design principle which become programming practices, and you have to follow through on what you're doing. And the big thing that people have to understand is that the concept behind it is that all data, basically all the data that you have related to something and processes related to that data are together in a single standalone unit that can operate independently or in conjunction with other units. Very simply put, is that you're trying to modularize and encapsulate all the data, make it independent, and be having those processes that relate to that data all to be together in one unit. These units are then called objects when they're actually running in the programs. These objects are instances of a class definition. In another video and other classes, we'll talk more specifically about what objects and classes are and how they define each other else. Let's continue though a little bit and look at what you're probably thinking is the real simple question of all this: why? Why in the world would anybody want to do this? Why is it necessary for people to be able to have to understand object-oriented, and why are we doing it? So let's take a look at two real-world examples about the concept that we're talking about. Let's take a first look at General Motors. You know General Motors, that big company. What does GM do? Think about it. What does GM do? Okay, they make cars. Some cars and trucks, etc. What they do. So they make vehicles, right? Some could say automobiles, could be trucks, but they make four-wheeled vehicles is what they do, right? And then does GM make one type of car? No. Think about it. It has Chevy, Oldsmobile, Buicks. It has different types of cars that it has. And inside those Chevrolet, Buicks, etc. brands, they have different models, right? And what makes up a car then? If you can have these different brands and then you can have these different models, what makes up a car, the components of it? Well, you need to have an engine, you need to have tires, you need to have wheels, you need to be able to drive it, you have to have gasoline, you have to have seats. So all those components are inside all those individual vehicles. Now, does GM make each model and brand use any unique parts? Does it? No, it doesn't. It uses the same engine on different models and different branded products. It uses similar types of wheel structures and axles and all those things. So what they do is they're able to interchange it between these different types of vehicles. Why? Why would they want to do that? Why would they want to be able to not have the same engine in a Chevy that's the same engine in a Buick? Well, the reason why they do that, think about it. So let's look at Microsoft. What does Microsoft do? Think about it. It's really a software company. It's always been a software company. Yes, they're attaching themselves to hardware now, but really they're a software company. And what are some of their products? Historically, the product has been an operating system. It has been the slew of Office products. There's Microsoft Word, Excel, PowerPoint, Access, things you may be familiar with. And there's other products similar to those. Does Microsoft make one type of application then? No, it makes a variety of different applications, don't you know? Like all those different applications are different. They have different, those software has different meaning and then different use, how they're applied. So then what makes up the applications? Well, think about it from the very basic. All of them, you're able to create files and store them, right? And all of them you'll be able to print from, right? All of them you'll be able to type in something. You can change fonts. You can do all those different things. Now, does Microsoft make each application using unique parts? Think about it. Are all those parts different? All the applications have the same look and feel, don't they? They have a menu bar that says File, and you can save files, you can print from there. Think about it. It's like GM, isn't it? GM has all the different components, and they can use them in different makes and models. The same thing with Microsoft. Again, why would they want to do this? Why do they want to do this? Okay. So let's ask ourselves then, why do those companies want to do things where they create different objects that they can actually put into different vehicles and they can make them run and make them work? And the same thing with Microsoft, they can take the print objects or the file saving objects, they can keep that and put it in different applications. Why would they want to do this? Well, first of all, one of the biggest things that companies want to do is make a profit. And the thing is that to be profitable, they also have to be more competitive. So one of the things they like is to be able to get a product faster to market. It's probably the number one reason why companies do the things they do, such as Microsoft, and the same thing with GM. So the same thing as they use in object-oriented principles, design principles, and programming practices is that one of the things is they can be able to get a product faster to market. You can develop software and applications faster to market by using objects. Secondarily, so therefore you can react quicker to market changes. As the demand changes for a different type of product or an application, they can very easily get into the market faster with it. Another way of thinking about it too is not only once you have the product made, how easy is it to maintain or upgrade? If you take a car to some GM dealer, chances are that all the cars that they have similar components, etc. The same thing with Microsoft. Therefore, it's easier to maintain if you know what the part is and the product is and the application has, and upgrade it. So whenever you need to upgrade, you just focus on that one little application or that little process inside there. So it's the same thing true with object-oriented design principles and programming practices. And one of the big things from all of this, if you think about it, again, it faster to market, make quicker changes, ease of maintenance, upgrade, is because it's very reusable. You can take something that you designed as software and reuse it in different applications. That's what Microsoft has done. The same thing that GM has done with their cars and their products. The other thing is then by doing that, you maintain a consistent quality or integrity of the products that you're putting out. If you are able to modularize these things into different objects and be able to componentize it that way, you're able to maintain consistent quality. Instead of duplicating this and trying to recreate over and over all the time software, you maintain a consistent quality integrity of your product line. Think about how Google works. Think about the Google applications they have and how they all work. Very, very modularized, similar to the Microsoft products. And the last thing is looking at componentization then is modularity that I've been mentioning about it, is that's a really big factor here. When you think about OO, especially as a programmer, even as a designer, what you're really trying to do is modularize it and componentize it so it's easy for you to work on something. There's a case here that I always say as programmers, work on small things at a time and test a lot. Build a little, test a lot. Build a little, test a lot. You can componentize it, can modularize it, and put all these pieces together in an algorithm that will work mostly effectively. So overall, if you leave and understand anything from this video, just make sure you understand why people are doing OO. It'll make sense to you. So let's look at the fundamentals of OO, the design principles and the programming practices. It's based on three simple fundamental abstract thoughts, basically. The first one is on data abstraction. Also, if you're looking at it from a standpoint of databases, we call this data independence. Basically, what it is that the data is going to be someplace that you don't know. Another object calls another object to use it because the data, or they're sending data there to be processed, and that one area just processes it. And you have no idea maybe where it's stored or how it's used. You just know that it's abstracted so that the data stands alone by itself, and the processes that are uniquely connected with it are abstracted, and you don't know. It's like going into a black box or going out into a black box or about into the cloud. Like you don't really know where it is or how it's done. You just know it gets done. That's data abstraction. The next is the concept of inheritance. One of the things about object-oriented principles is that you're going to have objects, and they can all be associated with different objects. They can be associated with each other. And one of the associations that is common is you're going to have inheritance, meaning that you can build something that has a very common thing that can be inherited down as many levels as you want. For instance, you can have one class that's the base for like 5 different other classes that become the base for other ones. Think about it like cars, or vehicles that GM makes. You'd probably want to have a base vehicle class, which you could then have, where it's going to have 4 wheels, a drivetrain, and an engine, right? And brakes. And then you'd be able to define it at one vehicle class, and then be able to come down to the next level of it and inherit all those things from that class. And the next ones, one would be a car, one would be a truck, and one would be a bus. Though it would be different designs. And then from all those, you can be able to go down even farther into more specialty cars, like sports cars versus coupes, etc., sedans. So you can see, just in your mind, think about how you can inherit things down by using object-oriented principles. Lastly is the concept of polymorphism. If you're going to be doing all these associations, especially inheritances, what's good about polymorphism, you can call it the same thing, but in each level of your inheritance, as you go down in your descendants, you call it the same name, but you can change how it actually works. Think about it. Does a man, a human, then to a man, and then if you go below that, and anything else, if you have differences, maybe there's a boy object, there's a man object. The boys maybe have a higher voice, and the men have a deeper voice. So you can actually say it could be different. Think about that. How can you change polymorphism itself? How can you change that? So if we look at everyone individually then, data abstracting is extracting data from a source upon request with no direct access to the data and no knowledge of the methods. Again, it's like going to a black box. Keep that in mind, that you're always going to be able to go out there, and all you're doing is one object that you're working from, is that you're going to be able to go out to another object and call upon it. It's based upon their association, what you're going to be able to do with it. Just like yourself. Do you talk to some people and they think about it and they're processing their way and they give you an answer? Only because you know them, you can ask them that question and then they will give you an answer, but you don't know what they're thinking about. So that's data abstraction. And that's where we talk about encapsulation. And you're going to hear me talk about data hiding, because you're hiding the data and you're encapsulating everything together. Again, inheritance is passing attributes and behaviors on to descendant generations. We're going to talk a lot more about this in examples of this in another video and in other sessions when we talk more about objects and classes and programming. But keep in mind that inheritance is simply passing attributes and behaviors on to descendant generations, and that there's some changes you can make in attributes as well as the behaviors. And that's when we get into polymorphism, meaning that many forms is behaviors within descendants may have the same name but provide different functionality. And those are things that you have to think about. So those 3 things make up the very core of what object-oriented is about. So understand the definition itself, object-oriented design principles and programming practices, where everything is contained in one self-standing alone unit, both the data and the behaviors of something, and we call those objects, which are defined based upon as classes, the value of it. You saw why we want to do this: faster market, reusability, etc. Understand that people aren't going to do this just because it's fun. It's because it really is going to pay off in the long run. And the fundamentals of it, again, are data abstraction, inheritance, and polymorphism. So as you look at and continue on with object-oriented, keep these factors in mind as you look at building out any programs. Thank you.